Hello everyone. Today's topic is about introduction to relations and functions. So let's see what's the definition of relation. A relation is a set of ordered pairs and it shows the relationship between two elements of two sets. The first element of each pair is from the domain and the second element is from the range. A relation can be visualized as a set of arrows connecting elements in the domains to the elements in the range. For example, the relation is a parent of can be represented as the set of ordered pairs where the first element is the parent and the second element is the child. So let's know about the properties of relation. The properties are symmetric, reflexive, transitive, and antisymmetric. Coming to the symmetric property, a relation is said to be symmetric if whenever the elements A, B is in the relation and also B and A should also be in the same relation. Coming to the reflexive property, a relation is said to be reflexive if every element is related to itself. And coming to the transitive property, a relation is said to be transitive if whenever element A and B and also B and C are in the relation and also B, A and C should be in the same relation. Coming to the antisymmetric, a relation is said to be antisymmetric if whenever elements of set A, B and B, A and also B, A are in the relation, then equals to B. So how do we represent our relations? Relations can be represented using different methods, each with its own advantage and disadvantage. One common method is using a set of ordered pairs. For example, the relation is greater than on the set of natural numbers can be represented by the set 1, 1, 2, 1, 3, 2, 3, 2, 4, etc. Another method is using matrix. For example, the relation is adjacent to. On the set of vertices of graph can be represented by an adjacency matrix. Finally, a relations can be represented visually using a directed graph. In a directed graph, vertices are represent elements of the set and directed edges represent the relation. We can see in this picture how do we represent relations and function using graph. Now let's see what is the definition of a function. A function is a special type of relation where each input maps to exactly one output and the domain of the set of all the possible inputs. The codomain is the set of all the possible outputs. Functions are widely used in mathematics and computer science to model the relationship between the quantities. So, what is the function composition? Basically, the function composition combines two functions, applying one to the result of the another, and it is written as g of f, g of x, where g is applied to the result of f of x. Example, if we take f of x is equals to x squared and g of x is x plus 1, then g of f of x will be equal to x squared plus 1. And the properties is that composition is not always commutative, meaning that is g of f of x may not be equal to f of g of x. Now let's see what is inverse function. A function's inverse undoes its original operation if a function uh, takes an input and produces an output. It takes inverse that output and returns the original input. To find the function's inverse, switch the roles of the input and output variables and solve for the new output. This process involves algebraic manipulation to isolate the new output, and the domain of the original function becomes the range of its inverse, and the range of the original function becomes the domain of its inverse. Now let's see what is one-to-one function. A one-to-one function is a type of function where each element in the domain maps to a unique element in the range. No two elements in the domain map to the same element in the range. To determine if the function is one-to-one, we can apply the horizontal line test. That is, a horizontal line intersects the graph of the function at more than one point, then the function is not one-to-one. For example, of a function f of x is equals to x squared is not one to one, as both x is equals to 2 and x is equals to minus 2 map the same value for f of x is equals to 4. However, the function f of x is equals to x plus 1 is 1 to 1, as each input maps to a unique output. Now let's see what is onto function. An onto function is a function where every element in the codomain has a corresponding element in the domain. In other words, all the elements in the output set are mapped to by some of the elements in the input set. Functions that are onto are sometimes referred to as surjective, that is, the range and the codomain of an onto function are equivalent. All the elements in the codomain are reached by the function. And the example we can take as f of x is equals to x squared with the codomain of all real numbers is not onto because the negative numbers cannot be obtained. However, the function f of x is equals to x with the same codomain is onto because all the real numbers are achievable output. So the application of the relations and functions are fundamental concepts in mathematics with the numerous applications in various fields. They are used in computer science, engineering, physics, and economics to model and analyze the real world phenomena.